Hi everyone, welcome back to Lulumath. This is the first video on solving linear equations, and we're going to be looking at how to solve one-step equations. Now, in this video, we're going to talk about how to solve one-step equations algebraically, even though these are probably equations that you can solve in your head. And the reason why is because we need to build our understanding of solving algebraic equations for when we get to equations that we can't do in our heads. So for starters, what are we trying to do when we solve equations to begin with? We are trying to determine the value of a variable or an unknown in an equation by isolating the variable. Now, how do we isolate the variable? We do inverse operations. And inverse operations are just opposite operations. So for example, an operation that we're familiar with is addition. And the inverse of addition is subtraction. Because, for example, if I were to take 5 and 7 and add them together, I would get 12. Now, if I want to start with this end number and I want to get to this 5, the way I would do that is by subtracting. So addition and subtraction are inverses of each other. They undo each other. So likewise, the inverse of subtraction is addition. Similarly, we have multiplication. And the opposite or the inverse of multiplication is division. Because I can take 5 times 7 and I would get 35. And then I can take that 35, my result, and to get back to the original number we started with, I would have to divide 35 by 7 to get back to that 5. So the multiplication and the division are inverses of each other. Likewise, the inverse of division is multiplication. There are some other operations that we can look at. Another common set of operations and their inverse would be squaring, and the opposite of squaring something would be to square root it. And it doesn't have to just be squaring, like cubing. The opposite of cubing is cube rooting. The opposite of raising something to the power of 4 is taking the 4th root. The opposite of raising something to the 10th power is taking the 10th root. So likewise, vice versa, square rooting's inverse is squaring. So let's apply this information to solving equations. So here we're trying to solve for x. We're trying to determine what is x equal to, and we'll do that by isolating this variable, this unknown. And since we're trying to get this x alone, we need to get rid of this minus 9 right here. And a quick note is what separates our two sides of our equations is an equal sign. So we see this equal sign right here, which means that this is the left side of my equation, my one side of my equation, and this is the other side of my equation. So the only thing on the left side of the equation that I need to get rid of is just this negative 9. Well, what's the opposite of subtraction? The opposite of subtraction is addition. So I'm going to add 9 to cancel this 9 out. Now, notice that negative 9 plus positive 9 is equal to 0. So I technically end up getting x plus 0 left over. However, x plus 0 is simply just x. So we don't even have to write this plus 0 here. We got the x alone. So it comes down to the fact that the additive identity, what you can add to anything at all to keep that number the same, is 0. So a helpful tip is that the additive identity is 0. So looking back at this equation right here, an equation is a balance. So whatever I do to one side, to balance it out, I have to do the same thing on the other side. Now, a really good question we have to ask ourselves is, why is an equation a balance? We have to know the answer to this so we can fully understand what we're doing when we're solving equations. So for example, if I had 5 equals 5. 5 equals 5 is an equation. The two sides of my equations are equal to each other. There's no variable in it, but it's still an equation. Now let's just add an arbitrary number, a random number. So I'm going to add 4. So if I add 4 to the left side of my equation, the left side of my equation is 9, but the right side of my equation is still 5, which is not true. 9 is not equal to 5. So this is no longer an equation. It's an inequality. It doesn't work. And the only way that I can balance this out is if I add 4 to the other side. Now I'm back to having an equation because my two sides are equal to each other. I could do 1 plus 2 on the left side of my equation, and on the right side of my equation, I can just write 3 because this is a true statement. 1 plus 2 is equal to 3. If I were to add 6 to the left side of my equation, then I would end up getting 1 plus 2 plus 6 is equal to 9. And 9 is equal to 3 is not a true equation, and they're not equal to each other. But if I add 6 to both sides, this will now say 9, and now it is a true equation. And that's why an equation is a balance, and that's why you have to do the same operation on both sides of our equation. Okay? So on my left side, I'm left over with just simply x. Again, because negative 9 plus 9 is 0. And really quickly, one last thing I want to say about that as well is that we can make sure that we're solving this equation correctly by making sure that these really do add up to give us 0. So always ask yourself that question. And negative 12 plus 9 is equal to negative 3. So that means that our solution is x equals negative 3. We've solved our equation. Now, you might be able to think in your head, well, I just know the answer is negative 3 anyways, because if I do negative 3 minus 9, I get negative 12, which you're absolutely right about that if that thought came to your head. The problem with that is that when we get into harder equations, you're not going to be able to know the answer off the top of your head. So we need to learn the process with things that make sense to us and apply it to harder level equations. All right, for this next one, we have 8 divided by negative 4 equals 14. And the variable that we want to isolate is this a. And the two sides of our equation are a over negative 4 and 14, because again, the equal sign separates the sides of our equation, which means this negative 4 here is what I want to get rid of. Well, what this is saying here is a divided by negative 4. And the opposite of division is multiplication. So what I'm going to do is I'm going to multiply by negative 4 here, and whatever I do to one side, I need to do to the other side. So right here, this is technically negative 4 over 1. So this becomes negative 4 times a, because when we multiply across, and this becomes 1 times negative 4, which is negative 4. But negative 4 divided by negative 4 is 1, so I end up getting 1a. But 1 times a is just a. I don't have to write 1a because 1 times any number is always that number. So here we're dealing with the multiplicative identity. So another helpful tip is that the multiplicative identity is 1. So here are two really helpful tips to make sure that we are solving our equations correctly, depending on whether there's addition or subtraction versus multiplication and division. Let's go back to this problem here. You're not expected to write all of this stuff out. Pretty much the biggest thing that you need to understand is that this negative 4 and this negative 4 cancel out. But when we say they cancel out to give us 1. And since we get 1 and 1 is the multiplicative identity, we just have this a left over here. So a will be equal to negative 56 because 14 times negative 4 is negative 56. And this is my answer because I have figured out, I've isolated a, I have figured out what the value of a is. Let's take a look at this last example. We've got 6 times p is equal to 39. My goal is to get this p alone. I want to isolate this p. And a reminder that 6p right here is one side of our equation, 39 is the other side. So all I have to get rid of is this 6. And since it's 6 times p, the opposite of multiplication is division. So I'm going to divide by 6, and whatever I do to one side, I do to the other side. So 6 divided by 6 gives us 1, so we get 1p. But again, 1 times p is just simply p, so we don't have to write 1p. And we know we did it right because we get the multiplicative identity. So these cancel out again, quote unquote cancel out, but again, it gives us 1, so we have a p left over, so p is equal to, now 39 is not evenly divisible by 6, so I can't say that my answer is a nice even integer, but They're both divisible by 3, so I can reduce it. So 39 divided by 3 and 6 divided by 3 gives me 13 over 2. Or we could say as a mixed number, it's just 6.5 because 2 goes into 13 6 times with 1 out of 2 left over. But we can write our answers as improper fractions. There's nothing wrong with that. That's it for this video. If you have any questions, let us know in the comments below or at lulumath.com, where you can also find blank or completed notes for this video. If you found this video to be useful, please make sure to subscribe and share with others. Thank you. We'll catch you next time. Bye.